All right. Now, now for our keynote. On behalf of IAPP Central Florida, we'd like to welcome Mr. Cameron.
Boozarjomehri, yeah.
Hi, all.
Now, he is also a fellow member of the IAPP and ISC Squared Tampa chapter member. He has a great talk today about exploiting data and rethinking privacy. So without any further ado, the camera's all yours.
So, as Derek introduced me, I'm Cameron Boozarjomehri, and I'm here to give a talk on behalf of my data privacy knowledge. I want to keep this talk very high level. I know a lot of times we go to these security and technology conferences. Hang on. Do you want me to turn the lights on? All right. Let me restart that. So I know a lot of the time we go to these technology conferences and we're saying, all right, I want to get in the weeds. I want to see how PowerShell works, all that stuff. This, because I'm focusing on privacy, it's very high level, but I think a lot of the points you'll see here is that it doesn't take a lot of effort to exploit data. This is something you'll commonly see with social engineering attacks. So we're just going to look at all the interesting ways that we've found to get data that we use through all the things we do every day out there, and then how those things can be exploited. Without further ado, a little more about me. I'm an associate of ISC Squared. I've sat for the test and completed it. I have a bachelor's and a master's, so I have an education, I'm employed, all sorts of stuff. All right, so let's start with framing the conversation. We're going to look at how we got to this point on how we collect data. We're going to explore what those data sets look like and why it's significant. And we're going to look at remediations for what can we do to fix these issues. But most importantly, we're going to think about control. Because at the end of the day, your data is probably one of the most significant things about you in the modern world. And being able to control how your data flows is crucial to being able to exist in the online age. So, let's frame the conversation. In the beginning, there was a Fourth Amendment, created by James Madison. During the pre-America world, or pre-United States world, where America existed under British rule, the British would do something called the general warrant, which they would say, we're going to go, we think there's contraband in Boston Harbor, we're going to search all the warehouses. If we find something, you're in trouble. The issue there is everyone is guilty until they don't find anything. And the Founding Fathers found that completely unacceptable. The Fourth Amendment said, you are secure in your own things, and I have to get a specific warrant that says, I want to search Cameron's property because he has contraband, or at least I believe he has contraband. So they were the privacy pros. They were the original people who thought that privacy was more significant than security. This was before America was, or the United States was even the United States. They were on the cusp of existence, and they were willing to sacrifice security because they believed in a citizen's right to protect their own privacy. Fast forward a long time to 1967. Katz v. US. So Charles Katz is placing interstate gambling bets at phone booths. The local law enforcement get wind of this. They say, hey, well, we know he's going to these phone booths, let's just mic him. The issue there was, when he was taken to court and it was appealed, went all the way to the Supreme Court, where they said, when he closed the door to the phone booth, he had an expectation of privacy. That meant that if you're going to record his conversation, you had to have a specific warrant for it. And so in this case, he got away with it. But, Smith v. Maryland, we have a different interpretation of this rule, which is a man by the name of Michael Smith robs a lady. That's just the long and short of it. And because he likes to add insult to injury, he had her phone number because he robbed her and stole her purse, and would drive by her house every day and call her and say, look outside. And his Monte Carlo, which she was familiar with because she was robbed by it, would drive by. So she obviously informed law enforcement because this guy had incredible hubris. The very next day, like the moment they found out about it, she got a phone call from him. And so the police were able to pull the record. Well, under Katz v. US, it's a phone conversation. Why are you able to just find out who was calling her? In this case, what they determined in Smith v. Maryland is phone records are not phone calls. We're not recording the conversation. We just know that your phone number called her phone number, and that is the metadata of the call. This has been crucial to how metadata collections and all the things going from the Patriot Act and all sorts of online metadata have become so readily accessible to the government. This is crucial to how data collection works today. So that's why when we found out the NSA was collecting information from T-Mobile's friend Verizon. These are the kind of laws that led to this metadata collection. And then there's more recent scholarly literature. So a personal favorite book of mine is Privacy in Context by Helen Nissenbaum. And the entire premise is privacy is completely contextually based. It's based on society, it's based on who you are as a person, and she defines it as a right to the appropriate flow of personal information. She also goes on to explain what appropriate is in giant walls of text. But the key here is context changes constantly. And so every application of your data, whether it's medical, school, finance, completely different implications for privacy. So now that we have all this fun literature and laws, let's get to some actual people who are saying specific things about what to do about privacy. Very recently, the FTC created the Fair Information Privacy Principles. And there's a fun acronym I have for it called NCASE. This helped me get through my group studies. You need to give notice. If I'm going to collect your data, I have to tell you, this is the context into which I'm collecting your data, this is why. I have to give you choice. I have to explicitly give you an opt-in and opt-out choice. You can't just say, yeah, I will not collect your data and then do it anyway. This is important because we've seen this a lot with ISPs in recent history. Real fast, if you don't know what an ISP is, it's an internet service provider. That slide I had earlier with T-Mobile and Verizon and Sprint, all those guys, those would be ISPs. You have to give access and participation. If I'm going to collect your data, I should give you an opportunity to update your data or at least have some sense of what the data is. You have to protect it. This is obvious, and up until recent FCC regulations, there was no real effort by any ISP to protect user data. And then there should be some sort of remediation. And the problem is, these are principles. There's no real tangible enforcement for this right now, like you see in other countries like Canada or in the European Union. However, there is an international organization called the OECD, the Oceanic Economic Cooperative for Development. And they took those principles and add 3 more, which I call DUB. It's obvious. It's data accuracy and integrity. So going back to that previous point, if you're going to make decisions about people based on the data you collect about them, it's really important that that data be up to date, because those could be the difference between you getting a bank loan or a car loan or any payments. There's a use limitation. If I'm going to collect your data because I need to know about, say, making a phone call, I don't need a lot of extra information. I just need to know who you're calling and who's calling that person. And then there's just honesty and openness. Don't do anything underhanded. If I say I'm going to collect my data for a reason, I'm clearly saying I want to collect it for that reason, nothing else. And I want to make it easy for you to ask questions about what I'm doing with your data. And so these are just how we've gotten to how we want to think about privacy today. But as we've seen, metadata collection is all over the place. So now that we've seen what privacy is supposed to look like in the modern world, I want to emphasize that privacy and security share a lot in common. So this is a room full of security experts or one day to be security experts. I want you guys all to remember that privacy actually has a lot of overlapping goals with security. ISACA documentation describes it as protecting against disclosure to unauthorized users or improper modification. CNS instructions is unauthorized access use disclosures. And back in 2003, Ventures and Olaf, a taxonomy of security technologies, described it as minimizing the risk of exposing information. I think it's kind of clear to see in these words that privacy and security are all about how are we controlling the data and how are we using it to protect the people we're collecting the data about. Also, if anyone actually wants to look this up, it's in Computer Security Volume 22. It's a good documentation, it's a good read. Anyway, I'm sure everyone in this room is familiar with the CIA triad, the principles that govern information security. So if you believe in these principles, you can see that privacy is at the center of all of them. And there's something that we should think about whenever we're designing new systems. All right, that's boring. Let's get to the actual attacks. Everyone likes just manipulating data, doing horrible things to people. Let's go. So, Netflix in 2006 created the Netflix Prize Dataset. They had, at that time, 480,000 subscribers. And if I recall, this is still when they were just mostly DVDs. They had a giant pile of data, millions of records, that they wanted to see if they could turn into a better algorithm. And in these records, it was pretty much just ratings. There was nothing about user information except for a unique ID that matched one profile to multiple ratings. So Netflix had an algorithm that says, if people like these movies, what can I tell about what other movies they might like? They wanted to turn that pile of data into a pile of money for someone. For anyone curious, Belcore's Pragmatic Chaos won that competition. They improved the algorithm's proficiency to it's like 86.4%, which means absolutely nothing to anyone in this room who hasn't seen it. But this is just a giant data set that was dumped onto the internet for the purposes of this project. It's important to think about what things can you do with the data set that don't align with the competition's goal. In this case, researchers at UT Austin in 2008 wanted to see what can we do about identifying people in this data set. So they wanted to see, is there another data set we can intersection attack? And remember, this is still like 2008. A lot of people aren't existing online making insane ratings of everything they do. And IMDb and Netflix, as far as ratings went, had surprisingly dedicated fan bases. So they wanted to see if we can overlap the data sets and normalize the data, can we identify a user that exists between both of them? And what they found was, if you eliminate the most popular movies, all the Star Warses and all the Lord of the Rings, you just focus on those niche, lesser known documentary whatever ratings, even if only 6 of those ratings match with an IMDb user, you can re-identify 99% of the individuals in the Netflix dataset. And
So you can map Netflix users onto registered IMDb users?
yes, and they did it by normalizing ratings, because Netflix uses a 5-star rating and IMDb uses a 10-point rating system at that time. So what does this look like when you're trying to actually do the data science behind it? It's based on something called K-anonymity, where you have a bucket that is supposed to be a certain number of users big. And a bucket is defined as a number of people that, if I don't know anything other than the information in that bucket, I can't tell which person in the bucket I'm looking at. The anonymity is the size of the bucket minus 1. So if I have 3 users, I have K-anonymity of 2. If I get down to just 1 user, if I find some special information that gets me down to just 1 guy, that guy has no anonymity, and I can identify him. This is common for research. In the case of the Netflix dataset, they released data by anonymizing it in a way that they didn't think would be able to identify any users inside their database. And as a result, people didn't think that you could identify people. So in the Netflix case, let's say that we have 5 people, and they all have 1 rating for The Incredibles. Their anonymity is 4. We add Captain America ratings, well, now we're getting closer and see that the anonymity for one group has suddenly dropped to 1. We add aliens, the anonymity is officially 0. I can identify each person in this data set uniquely. And once we add the room, we know that Michelle has terrible taste in movies. So movies are cool and all, but what happens when we get to some more consequential data? Researchers at my alma mater, Carnegie Mellon, in 2002, purchased Cambridge area voter information for $20. That is just available online. Everyone knows voter information is public record. It's out there. It contains this weird-looking pile of information with these fields. Then, the insurance company that managed all government employees in the Cambridge area was selling anonymized records to industry purposes of, at that point, really anything. Were they trying to find new customers? Were they just looking for research data? Who knows? But they're also giving it away to university researchers for free. So $20 for voter information, a free data set, and using just zip, birth date, and sex, researchers were able to re-identify the governor of Massachusetts. This joke brought to you by Mess. So that's just when we're doing like normal spreadsheet analysis. Can we do something a little more invasive? What if we could find where someone is? The New York taxicab data set is actually an ongoing data set. It's released by the Cab and Limousine Service of New York City. And it has trips going back all the way to 2009. It's a robust data set. It has information about license numbers, medallion numbers, pickup and drop-off locations, and drop-off times. A quick caveat about the medallion numbers. They are, I think they're MD5 hash, but there's no salt. You can brute force your way through it, no problem. At least that's what the researchers did when they got all this data under Freedom of Information Act. So, the Riding with the Stars research project wants to explore how can we identify people in this data set? What can we learn about their trips? And this is really just a case of people Googling for the people they want to target. I know it's kind of small, but can anyone make out who that is? That's Bradley Cooper, yeah! So, this is Bradley Cooper's taxi ride. This is GPS coordinate taxi ride. This is what we learned from it. He was going to Melibea in Greenwich Village, a very high-end restaurant, and he paid $10.50. Can anyone make out who this is? Yeah, you're great at this. All right.
We know what you do in your spare
Yeah, you're a social engineer by trade, aren't you? Anyway, this is Jessica Alba. Did you take these photos? So, yeah, sorry, real fast. These are paparazzi photos of people getting in and out of cabs. And in Jessica Alba's case, we know she came from the Trump Soho where she was staying, and she paid $9, and she did not tip. As far as we can tell in the data set, I don't know if cash tips carry, but we knew that Bradley Cooper did leave a tip even though it was cash, so I don't know what that says about Jessica Alba. So these are just paparazzi photos. What if I wanted to get into more machine learning data analytics? Let's see how many people go to strip clubs after work. The blue dots are all pickup locations associated with government offices within, like basically right in front of the building. And the yellow is drop-offs. I know what you're thinking. How do I know people weren't just going home? Maybe they just happened to be strip club adjacent. Well, Larry Flynn's Hustler Club is a surprisingly isolated location, so unless they wanted to walk for a very long time, they were probably going there. But the point here is, you can do so much with data. And this data is data that was, for many reasons, freely available for the purposes of research, city planning, or just medical examination. But we need to find ways to think about how this is causing harm. And we're not going to get solutions just yet. I want to give you guys, these are older examples. I want to give you an update on how we're collecting this data now, right now. So, first of all, FCC privacy rules. Remember before I mentioned ISPs are doing not such a great job collecting or protecting our information? The FCC passed privacy rules to give us more transparency into how they're collecting that information, and the Senate undid them in April. Like, they're gone. They're completely gone now. There's none of these protections are in place. These government ISPs who can now freely collect and sell consumer data, as they were doing before, they have no more opt-in, opt-out requirements. Right now, FCC Chairman Ajay wants them to sign on to a self-enforced policy of, if we say we don't collect your data, we won't. But there's no transparency into how they're actually doing this. And that's just the point. There's no more transparency into how our data is being collected and then shared. We don't know who's being sold to, if it's being sold, what data is being collected, or for what. And that's just your internet traffic. We have all sorts of big data companies like Uber that's trying to build analytics and their own version of city planning or APIs to help consumers and city managers. This data set was released by 538. The previous one was an Freedom of Information Act for the purposes of just that research. Then, this is the Florida voter database. So, anyone in here a voter in Florida? All right, you're gonna hate this. So, the Florida resident database, I can look for anyone by name, by email address, by phone number. There's no stopping me just clicking on any one of these things, and if I know enough about your name, I can find your voter information. And it's true for these 4 states as well. This is freely available. You guys just Google this and you will find it.
Huh.
Yeah. And then, as far as the medical record collection was concerned, we have Florida Section 400.145 was the Florida statute saying that if nursing home residents were okay with it, their medical data would be released upon their death for medical purposes. So this is information like name, address, patient information, maybe even some information about them. That would be, as we saw, they would try to anonymize it, but we saw what happened before when they tried to anonymize a large data set and thought nothing bad would happen. And we just saw that we have a giant database that exists online that people can query very easily. So in regard to how much of a predicament this law was, Opus Management takes the ruling to the 11th Circuit Court of Appeals in Florida, and they determined that the law is preempted by HIPAA. So this is another case of laws coming to the rescue to help protect our data. But the law had already been in effect for the law, so what does that mean? Anyway, just real fast before we move on. Thank you, HIPAA, for saving our medical records and the implications therein for consumers and their spouses and families. And also, I opt from now on that HIPAA be the mascot for HIPAA. Go to the website, find it, sign up. Okay, so up until now, we've seen that data is just getting out there, and so far the only remediation we've had is laws. I want to show you guys how technology can really play a big factor in helping protect people's information. Because one of the biggest problems with privacy is once your data is out there, you can't get it back. That's just a fundamental fact of the internet, is there's no undo button. So how can we fight this problem? Well, in Uber's favor, they've been working on summarizing tools. So instead of having explicitly specific information about individual rides, they've built APIs that say at this time, this number of people were picked up in this location, dropped off in this location. So those trips are buckets. But we have to be careful, because if you have a bucket of 1, you can uniquely identify an individual, and that, if you are the one person harmed by a data set, doesn't matter how well they did for everyone else, it still annoys you. You can also, and this is a very high level I'm trying to state, but there's a lot of research going into what's called differential privacy. So I'm going to try and explain this as well as I can, and hopefully I can do a better explanation later if anyone has more questions. But let's say we have 2 data sets, one with your data and one without it. They're not equal. If I do a summary analysis, I try and find how many people have your blood type. Between the 2, they're not equal. Differential privacy says we can basically apply math. There's some sort of way we can apply noise to the algorithm, or algorithm that applies noise to the data, that makes it so that the data matches. And if I'm querying the data, I can't tell the difference between if you're there or not. This is tweaked by a value called epsilon, but for the point of this talk, I'm trying to say that there are ways to, based on what you're trying to do, computationally protect people using noise. So what does that look like in practice? Well, anyone who's technically savvy or curious enough can go check out something called Privacy Integrated Queries, built on the LINQ.NET language. So if you can tolerate .NET, go for it. Created by Frank McSherry, a researcher at Microsoft Research Labs, who will not return my emails. And his research has created a platform that allows you to apply data privacy to a large data set. In this case, I was working with giant spreadsheets of taxicab information, but I ran it through the ping process where you can limit the number of queries. So the inherent problem is if I do enough queries where I tweak the data just a little bit, can I still pull out one person? This system allows me to limit how many queries I'm able to do based on what the actual data I'm trying to look for is. At the same time, you can see here that how you apply this technology to data can have drastically different effects. For trip volume, no matter how much I play with the noise values, you can see that the trend is pretty tight. You can assume that it's pretty much the same throughout the week, or throughout the day. But when I'm playing with average speed, my epsilon values can drastically change how I expect the traffic to be behaving at any given time, even though it's the same data. This is a sign of technology's coming a long way, but we still have a ways to go to figure out where that sweet spot is, where we're protecting people and still creating usable systems. Same thing is true for the heat map idea that we saw Uber do for their approach to this exact same problem. If I have a very high epsilon, that means I don't have that much noise and my data tightly fits what I would expect. If I had too much noise, and this is especially a big problem for geospatial data, I'm dropping off people from my taxi ride in the middle of the river. Doesn't make any sense. So now we have 2 problems. One is how do we apply the technology? 2 is how do we account for unexpected data or data that is incorrect? Apple, I will point out, wants to allow people to sign up, and they will apply differential privacy to how they read your iCloud information to improve their systems. I have no idea how well this is going to work in practice, but if Apple wants to give it a shot, go for it. Oops. What we saw with the Florida voter database, there's actually a lot of stuff you can do that's very simple that will help minimize the ability to scrape a large data set very easily. Guess one of the biggest problems is that website I showed you before, that's just a form field. I just send it some information, and it returns me a bunch of records about a bunch of people. This is the one time Louisiana is better than Florida. This is the one time I'll admit it. My girlfriend watching this, this is the one time. Here you can search by voter, view election results, or search by parish. Well, I search by voter, or if I search by result, I get some information about who won by how much. If I search by parish, I just get voter information about that parish. Where am I supposed to go? Where is the expected election, and so on. But the important part is what happens when I try and look for some guy. If I just type this information without at least the zip code or the birthday, I can't proceed. This is a minimal security application about, make sure the right guy gets in. I think there's like a million papers named that. And all of them are basically based around this. Just what is the minimal information that if I'm looking for a specific person, such as myself, there's ideally some information about me that's not easy to get at. The problem, of course, with the data is once it's out there, it's out there. If I'm really that dedicated, I can probably find that data about you. I can't scrape this website that easily. And so it adds some privacy value to the consumer. And then there is just the idea of making noise. If I don't want people collecting my information, I will give them terrible information to collect. There are things called Track Me Not and Ad Nauseum, which are web browser plugins. And all they do is generate random noise about your browser session. So it makes it harder to identify specific information about you as a user. But the problem with browser plugins is browser companies who are trying to collect this data don't like that. They're going to do everything they can to make sure they get that nice clean data to maintain their product. Other companies create something called internet noise, which just spawns tabs that are completely random, ideally blocking your browser session. And then those same companies expect you to install information about how are you being protected, protecting your interactions more, donate to the EFF, install a VPN. There's so much going on, and it's not fair to the consumer to put this much responsibility on them just to protect basic information about them when they don't want to collect it. And that's part of the problem, is we don't have a choice right now. We're trying to build technologies that give us some control back. But with noise, you have two inherent problems. One, these technologies can be blocked. And two, what happens when the algorithms are going to accept this noise anyway? There's been a lot of research to get that golden data, but if you have algorithms making decisions about people, and they have a lot of noisy data that doesn't actually represent people, it can affect the outcomes that have real consequences on real people. So, to recap, privacy is fundamental. Founding fathers believed it, you should too. Privacy and security have overlapping goals. I hope in my talk I've shown you that lots of data can get out there very easily, be re-identified just as easily, and have serious implications to any individual harmed by that disclosure. That can go on to be a social engineering attack, or be significant information about individuals in general that can go on to be identity theft. And even the most innocuous data can be revealed. Sometimes you don't know how that metadata can be used tomorrow, or what other complementary data set's going to be out there. So we need to think about how easy we make it to get access to how much information. Thought the Netflix data set wasn't too bad? Oh, come on. But then we found that with just as much effort, we can find out how many people are going to strip clubs. We need to rethink how we share. Sometimes small technology changes can help enhance privacy, even if it's not perfect. We need to consider our data sets, how much data is getting out there, and how unique is the data in that set. And we've got to think about noise. Noise is great sometimes. So, going forward, I hope all of you in your security professions, or if you join the IAPP and become a privacy anything, remember NCASE. You want that notice, you want to get consent, you want to protect and you want to provide access and protect the data, and you want to give some enforceable remediation. At make sure that people are maintaining the data and doing everything in their power to keep them in the loop. And then always ask what the data is for. If the data is not for something that you explicitly asked for, maybe you shouldn't be collecting it, and you definitely shouldn't be using it. So I hope you've enjoyed this journey with me. Here's some closing thoughts for you. Privacy adds value. If you can demonstrate that you're adhering to these principles, you're building confidence in how you're going to maintain people's information. And by extension, you're building trust that people are going to want to use your product because you're doing something valuable for them that other companies might not be doing. And when you really examine your products in this way, when you're looking at your full data lifecycle, thinking about the onward sale and what those implications are for your consumers, you can see more into how this information can go back to harm your own company and demonstrate to individuals what they can do better. So if you want to get some knowledge towards where I come from, feel free to check out just IAPP recommended readings, Privacy Invading Technologies, the Smart Grid. You'd be surprised how much a Smart Grid can tell you about individuals, and of course my favorite, Privacy in Context. I also like podcasts. Code Breakers is good. I think they're still on break. Note to Self is pretty fun. And Decrypted is by Bloomberg. They do it from their technology desk. And if you can tolerate Reddit, go check out our privacy, and there's our Euro privacy if you're into that kind of thing. So, for my final thought, I want to leave you all with this quote. Right to privacy is a right to the appropriate flow of personal information. That's all we really want. No one can expect to have a grasp on their data unless they completely fall off the grid. That's just not a reasonable solution. What we want to do is, when we're expecting to give our information, for in this case a phone call, we want to make sure that only the information we need to give away is given. Sources, more sources, more sources, these will all be in the slides. And big thanks to Derek and everyone who volunteers to make ISC squared and the ISC